Okay, my last clip got cut off. Sorry about that. As I was saying, the tough part about this, and it's not really tough, it's maybe confusing, is that sine is paired with cosecant. So even though it sounds like it should be paired with secant, sine, secant, it's actually sine and cosecant. So the cosecant of s is going to be the reciprocal of the sine. I would go ahead and not reciprocate this last one, but I'd reciprocate one of the first ratios. That way, when you flip it, you end up with the square root of 10 over 3, and you don't have any rationalizing left to do there. Okay, cosine is paired with secant. So the secant of s is going to be the reciprocal of cosine. Again, I'd go back to one of the early fractions and flip that one, because then when you just do the square root of 10 over 1, well, that's just going to end up being the square root of 10, and you're done. And then lastly, obviously, tangent is paired with the cotangent. So you're going to take the reciprocal of 21 over 7, which is 7 over 21, which ends up simplifying to be 1/3, or you could have reciprocated 3 as well. On the back page, number 11 says, generate the first quadrant of the unit circle, including 0 degrees and 90 degrees, by writing the angle measures and the xy coordinates of its terminal side. This is super important, guys. If you can do number 11, it's going to help you with the rest of the entire study guide and consequently so many questions on your test. It's just quadrant 1. So if I start with 0 degrees here, and then I'm going to end up with 90 degrees up here. 0 degrees, the coordinate there is 1, 0, right? To the right 1, and then don't go up and down. And then the coordinate at 90 degrees is 0, 1. There are 3 angles in the first quadrant, and think about it, we did our special right triangles. So one of them is 30, 60, 90, and the other one's 45, 45, 90. So those are your 3 angles there, the 3 different ones. You're going to have 30, and then 45 and 60. So obviously 45 is going to cut this sucker. Oh, lovely line. Let me see if I can make that better. Okay, it's a little bit better. If that's 45 degrees, you could either do your special right triangle, right, which drops down the leg here, and then say, okay, if my radius is 1, do Pythagorean theorem to figure out all the other stuff. Or it's probably just good to remember what the coordinates are at 45 degrees. They're going to be the square root of 2 over 2, comma, square root of 2 over 2. That one's the same because the legs are the same lengths there. It's an isosceles triangle. So that's at 45 degrees. And then you're also going to have 30 degrees somewhere over here, at which point you're going to have the x-coordinate's going to be a little bit further out, a little bit further to the right. So that one's going to be the square root of 3 over 2, and then 1/2. And then the 60 degree angle is going to be opposite of the 30 degree angle. So I say opposite. It's going to be the x-coordinate and the y-coordinate swap. So that one's going to be 1/2. And then square root of 3 over 2. So there's some ways that you can, I hate to say put this to memory because you can figure it out, but notice the x-coordinates, if I start with 30 degrees and move up, it's the square root of 3 over 2, the square root of 2 over 2, and then technically this is the square root of 1 over 2. And then the y values go opposite. The y value starts off as the square root of 1 over 2, the square root of 2 over 2, and then the square root of 3 over 2. So it goes in order, and it's actually not so daunting once you realize some patterns like that. Okay, we're going to keep referring back to number 11 to help us with some more of these problems. So for number 12, it says use the unit circle to find each value. So for part A, it wants us to find the cosecant of 90 degrees. Well, the thing to remember here is that cosecant is paired with sine, right? So if you remember that the sine of, we'll just say some angle alpha, is y over r, and again, if we're in the unit circle here, we know the radius is 1, then the cosecant is going to be the reciprocal of this. So the cosecant of 90 is going to be r over y. Well, again, we're in the unit circle, so we just need to figure out what this ratio is. In the unit circle, the radius is 1, and in the y value at the 90-degree angle, so again, go ahead and refer to your unit circle number 11, the y value at 90 degrees is 1. And then if you simplify 1 over 1, you just get 1. So the cosecant of 90 degrees is 1. For part B, the tangent of 270 degrees. If you think about where 270 degrees is on the unit circle, so I'm going to draw a sketch out here. All these count by 90, right? So if that's 90, this is 180, this is 270, and this is 360. So 270 is going to be this ray right here. That coordinate is going to be 0, -1. So tangent is slope, right? Slope is rise over run, so it's going to be y over x. So all I need to do is take this coordinate points, and if I put y over x, that's going to be -1 over 0. Well, division by 0 is not allowed in math, so the tangent of 270 degrees is undefined. And think about that for a second, guys. We said that slope, or tangent, was slope. So the slope of this line here, it's a vertical line, which you knew coming into this class already that vertical lines have undefined slope. So there's the trig proof behind that. For number 13, it says use the unit circle to find the values of the 6 trig functions of 120 degrees. Hint, if necessary, find the reference angle first. So I need either SOHCAHTOA, so I either need to draw a triangle, or I need to know what my x's and my y's, and obviously the radius in the unit circle is 1. So I needed to know what are the x's and the y's for 120 degrees. Well, if you don't have your full unit circle committed to memory, and good golly, that's a lot to remember, find the reference angle first. So if you use what we talked about on the other page, 120 degrees is in the second quadrant. Right? So in order to find something in the second quadrant, if I find its reference angle, I'm going to take 180 minus 120, and I'm going to get 60 degrees. So 60 degrees is the reference angle to 120 degrees. So how does that help us? Well, if you have your first quadrant, and you go up there and you look at your 60-degree angle, its coordinates are 1/2 square root of 3 over 2. So what that means, 1/2 square root of 3 over 2. So that means the 120-degree angle, remember this is the quadrant 1 reference angle. 120 degrees is in quadrant 2. So what you need to remember in quadrant 2, all of your coordinates have the symbols -x, +y, right? Because they go to the left and then up. So I'm going to take my reference angle. I know it's going to be the same two numbers, except my x value is going to be a -1/2, and my y value is going to stay the positive square root of 3 over 2. So for 120 degrees, I know these are my coordinate points that I'm going to use. So when I need to find the 6 trig functions, I'm going to use those two coordinates there. So the sine of 120 is equal to the y value, which is just the square root of 3 over 2. The cosine of 120 is the x value. Again, it's technically y over r and x over r, but since we're in the unit circle, we know that r is equal to 1. So the x value is just -1/2. And then lastly, the tangent of 120, slope is y over x. So we're going to have the square root of 3 over 2 over -1 over 2. And this is kind of confusing, but if you remember that a fraction divided by a fraction is the same thing as doing the square root of 3 over 2 times the reciprocal of the second fraction. So the reciprocal of -1/2 is going to be -2 over 1. Then we can multiply straight across. So then I get -2 square roots of 3 over 2. Well, -2 over -2 is just -1, so this reduces to be negative square roots of 3. So there's the sine, cosine, and tangent. To find the other three, we're just going to take the reciprocals of these three. So the cosecant of 120 is going to be 2 over the square root of 3, but we need to go ahead and rationalize that by multiplying by the square root of 3 over itself. So then we get 2 square roots of 3 over 3. Cosine is paired with secant. So the secant of 120 degrees is going to be the reciprocal of negative 1/2, which is negative 2 over 1, which is just negative 2. And then the tangent is paired with cotangent. So the cotangent of 120 degrees, you could go back to the very beginning and then multiply by the reciprocal, but switch the order of your fractions, or just go ahead and reciprocate one of your, let's just do the final answer there. So if I take the reciprocal of negative square root of 3, then I'm going to have negative 1 over the square root of 3 is the reciprocal. And then we have to rationalize this still. So it's going to be negative square root of 3 over 3. Number 14, find the values of the 6 trigonometric functions for an angle theta in standard position if a point with the given coordinates lies on its terminal side. So what this means is we're no longer in the unit circle. That means I'm taking some angle in standard position and I'm going to rotate it such that whenever I stop the rotation, this point is on that terminal side. So essentially we're just going to graph that coordinate point. Negative 1, so it's going to start at the origin and go 1 to the left and up 5. And it really doesn't matter if they're like exactly correct. The idea is just to get a ballpark. So that means we took some angle in standard position and we rotated it counterclockwise such that, oh, lovely symbols here. Sorry, I'm not as good as Khan. Maybe I'd be good at him one day if I get better with this. So if we rotate this counterclockwise, that means on our terminal angle, that point lies there. So then if I go ahead and make a right triangle, oh, a beautiful right triangle. This is harder than it looks, children. Okay, if I drop this down vertically, it's a little bit better to make a right triangle. We want 1 to the left, so negative 1, and then up 5. So if I want the 6 trigonometric ratios, again, we're just going to call this angle theta somewhere in the middle, where our central angle is. We need to first solve for the hypotenuse. So we're going to use Pythagorean theorem for that. So if I do 5 squared plus negative 1 squared equals c squared, that's going to be, what, 26 equals c squared. So then c is going to equal the square root of 26. So then you can label that on your triangle. Square root of 26. And now we can proceed finding the 6 trig ratios. So starting off with sine, the sine of theta. Okay, the sine of theta. You can think about it if you want as y over r, or you can think just with regular SOHCAHTOA, opposite over hypotenuse. They both mean the same thing, it's just kind of your mental preference. Either way, you're going to get 5 over the square root of 26, which we need to rationalize and multiply straight across. So 5 square roots of 26 over 26. The cosine of theta is adjacent over hypotenuse, or x over r. Either way, negative 1 over the square root of 26. So again, I want to clarify, the radius in this case is the hypotenuse of the triangle. And then we have to rationalize this guy as well. Multiply straight across, negative square root of 26 over 26. And then lastly, the tangent. You could either think about it as y over x or opposite over adjacent. Either way, 5 over negative 1 simplifies to be negative 5. And if you can get the 3 basic ones, then the other 3 are going to be the reciprocals. So cosecant of theta is going to be the reciprocal. Again, don't do the reciprocal of your answer, because then you're going to have a radical in the denominator. So go back to that original ratio and flip that one. So the cosecant is just going to be the square root of 26 over 5. The secant is just going to be the square root of 26 over negative 1, which can simplify to be negative square root of 26. And then the cotangent is going to be the reciprocal of negative 5, which is just going to be negative 1/5. For 15, it says, looking down at a boat from a 30-meter high lighthouse, you measure an angle of depression of 15 degrees. How far is the boat from the lighthouse? And of course, draw a picture. So if you have a lighthouse, look how great this lighthouse is going to be. Doesn't there have to be a light on a lighthouse? I don't know how to draw a lighthouse. Let's just do this. Hopefully you know that that's my lighthouse. Okay, that's 30 meters tall. And somebody from the top of that lighthouse is looking down at a boat. So if this is the water down here, we'll say the boat is somewhere out here. And the angle of depression is 15 degrees. If you recall from our notes, angles of depression are at the top. So even though depression means kind of feeling down, you think about it as falling down. So starting at the top and falling down. So 15 degrees. Question is, how far is the boat from the lighthouse? So then if I finish the right triangle and I put that value as x, that's exactly what we're looking for. So to solve these, I like to go ahead and list out my information that I know and information that I need. First, we need a reference angle. So I'm going to choose 15 degrees just because. From that point of reference, I know the length of 30, which is the lighthouse, and that is adjacent to that angle. And I need to find the x, which is opposite of angle 15. So if I think SOHCAHTOA, if I look at sine, cosine, and tangent, I want to choose the one that has adjacent and opposite, which is why I'm going to choose TOA or tangent. So then we set up the ratio. Tangent of 15 is equal to opposite is x over adjacent is 30. And then all we need to do is isolate and get x by itself. So then if I multiply both sides by 30, then I get x equals 30 times the tangent of 15. Now, before you plug this in your calculator and chug along, you've got to make sure that your calculator is in degree mode. So hit the mode button and verify that it says degree. Remember, calculators always go back to radian mode, so you need to double check and make sure that yours is in degree before you type this in your calculator. When you do that, you should end up with a distance of about 8 meters. The boat's going to be about 8 meters from that lighthouse. Number 16, solve each equation if the angle x is between 0 and 360 degrees. So for part A, it says the cosine of x is the square root of 2 over 2. So what I need you to think of, remember, is that the cosine is the x-coordinate, right? So I basically need to think about, using my unit circle, where or what x-coordinates are the square root of 2 over 2. So I'm going to scroll back up and we're going to look at my first quadrant. In the first quadrant, there's only one answer that has the square root of 2 over 2, and it's 45 degrees. So that's one of them, but that's not the only one. If you picture the rest of the unit circle, that 45 degree angle, so let's see like this. If this has the x value that we need, then whatever this angle is, 45 degrees away from this side will also have the same positive x distance that we need as well. So if that's 45 degrees, and then we want 45 degrees away from the other end, if we take 360 minus 45, then we're going to end up with 315 degrees. And if you look at your pie plate, or that original paper plate that we made, you'll see that the 315 degree angle down here in quadrant 4 will also have the square root of 2 over 2, except its y coordinate's going to be the negative square root of 2 over 2. Okay, we're going to do the same kind of logic for part B. I need to know where the tangent of x is equal to 1. Now remember, tangent is slope. Tangent is y over x. So if I go scroll up and look at my first quadrant, I need to look at the coordinates and figure out, okay, when I put y over x, what gets me 1? Well, 1 over 0 is 0. The square root of 3 over 2 divided by 1/2 is definitely not 1. We know that 1 is anything divided by itself. Well, again, 45 degrees. The square root of 2 over 2 divided by itself, the square root of 2 over 2 is going to be 1. So that 45-degree angle is going to be another 1. But again, you need to picture the rest of the unit circle. We need to figure out where else. So we knew that this was positive square root of 2 over 2, positive square root of 2 over 2. So we need to know where else are we going to have those same results. Where both of these were positive, if we use that same angle, which we used over here, which is 315, that one's positive, negative. So if we divide them, that's going to give us a -1. And same thing over here, that one's negative positive. So that's going to give us -1. So the only other one that's going to give us a +1, and think about, remember, tangent is slope. Hello, going through the origin. That's going to be a slope of 1, is going to be this angle that's going to be 45 degrees off of 180. So then if you add 180 plus 45, you end up with 225. So those are your two answers for 16 part B. 45 degrees and 225 degrees. Okay, number 17, evaluate each expression assuming all angles are in quadrant 1. So these can be a little bit tricky. What you have to remember is, and this is going to be one, I can tell it already, it's going to be on your test. You're going to go, oh, I remember she did it, I just don't remember how to do it. Study and make sure you remember how to do this problem. If you have the tangent of the inverse cosine, or in fact, any question like this that has two different functions, so one's tangent, one's cosine, one's sine, one's cosecant, whatever, I want you to say, okay, well, let's set this stuff, and let's just call that x, okay? So what that means is, then I can say x is equal to, let me write this over here. That means x equals the inverse cosine of 2/3. Okay, well, if you remember, we can undo trig functions by doing the opposite. So if I want to undo cosine inverse, then I can take the cosine of both sides. So this is going to look kind of weird. Oh, maybe I should write it elsewhere. Bear with me. Okay, so if I say x equals inverse cosine of 2/3, if I want to undo inverse cosine, I can take the cosine of both sides, because those are opposite operations. So it's the same thing as if something was being multiplied and I decided to divide it, or vice versa. So if I take the cosine of the left side and the cosine of the right side, then on the left side, I'm left with the cosine of x, and on the right side, cosine times cosine inverse is, well, that cancels. So basically, they disappear. And all you're left with is 2/3. So the cosine of x is 2/3. Now, what can we do with this? Well, we can draw a triangle and figure out, okay, what does that look like? Because ultimately I need the tangent, and the tangent is opposite over adjacent. So I need some kind of reference for a triangle to figure out what each part of it is. So if I call this angle x, cosine is adjacent over hypotenuse. So it means adjacent from x we have 2, and the hypotenuse is 3. So I want to solve for this opposite side. Let me call it, we can just call it y since we used x already. So if I use Pythagorean theorem and I do 2 squared plus y squared equals 3 squared, I end up with y squared is equal to, let's see, 9 minus 4 is 5. So then y is equal to the square root of 5. So that's the leg of this triangle, is the square root of 5. So then if I ask you for the tangent of x, remember I substituted and I made all of this equal to x, then the tangent of x, now that I've simplified everything out, is opposite over adjacent. Well, opposite is that y value, which we just solved for, is the square root of 5. And adjacent to that is 2. So the square root of 5 over 2. For B, this one's a lot easier. It says, what is the sine of the arc sine of the square root of 3? Well, sine and arc sine, remember, arc sine is essentially the same thing as sine inverse, and arc cosine is the same thing as cosine inverse, and arc tangent is the same thing as tangent inverse. These are all the same ways of talking about things, and essentially they are inverses of sine, cosine, and tangent. So if I take the sine of arc sine, I'm basically doing something and undoing it, because I just did something and put the inverse in the same problem. So the answer here is just the square root of 3. So if I did the tangent of arctangent of something, same thing, my answer would just be the number on the inside. Okay, last question. Solve the triangle completely. There are 3 angles and 3 sides to every triangle, so I want to know, other than the information that I provide you, what are the remaining angles and sides. I do the easy stuff first. I notice that I have a right triangle, so this angle is 90, and this angle is 25. Did I just type the number 5? I think so. Disregard that. So if I want to find my third angle A, all I need to do is the 3 angles in a triangle add up to 180. So 180 minus 90 minus 25 is going to equal 65. So that's pretty easy. Angle A is going to be 65 degrees. And then all that's left is for me to find 2 sides. So please know there are so many different ways that you could approach solving for the sides. It's totally up to you. I'm just going to do what comes to my brain first, which is if I choose a reference angle of 25 degrees, and from 25 I say, okay, I have 8, and I know 8 is adjacent, and I want to solve for B, which is opposite, then if I look at SOHCAHTOA, I can use the tangent to solve. So if I take the tangent of 25 is equal to opposite over adjacent, so that's B over 8. And I solve for B, if I multiply both sides by 8, I get B is equal to 8 times the tangent of 25. And then if I type that into my calculator as is, I didn't tell you how to round. Let's just round to the nearest tenth for now. And then B is going to be approximately 3.7 meters. To find C, you could use sine, cosine, or tangent again, or if you like Pythagorean theorem, then you could just do that, because then you can say, okay, 3.7 squared plus 8 squared is equal to C squared. If you do that, you get 77.69 equals C squared, and then when you take the square root of both sides, you end up with C is approximately 8.8 meters. So you have all 3 sides now and all 3 angles. That's what it means to solve the triangle completely. This concludes the study guide tutorial. I know I went pretty quickly, but remember you can always pause and rewind, so to speak, if you need to. If something is still not clear, shoot me an email, or if you feel like I made a mistake, which is highly possible because you know me, shoot me an email and I'll try to see if I can help you via email if this did not help enough. Happy studying!